Hey everyone, welcome back to our Sky Tonight program. This is Seth Mayo, curator of astronomy for the Lowman Planetarium. Glad to see you back here. And in this week's episode, we're covering the dates of January 25th through January 31st. And what we'll talk about for this week's sky is the planet Mercury off to the west in the evening. I'll show you where to look, and we're going to fly to it digitally, talk more about the planet in a three-dimensional environment. Then we're going to go back to Mars and again mention the Perseverance rover landing there very soon, and we'll end things with our full moon that happens by the end of the month. So let's get to it. So this past Sunday on January 24th, you may have recalled that we talked about Mercury being at what's called greatest elongation east. And that's when Mercury is most east of the sun in the sky, and that means you see it highest in the evening. So if you go out after sunset, about 30 minutes after your local sunset, and you look towards the west and southwest, and I have that set now right here in Stellarium, you may have a chance, if you have a very unobstructed and clear view of the horizon, you may have a chance to see the planet Mercury located right down here. And Mercury is a very fleeting planet. You usually don't have much time to see it, and it's near the sun usually, so it does make it kind of difficult to spot. But this is the best time to see it when it's farthest east of the sun. Again, that occurred technically on Sunday the 24th, but it kind of remains that way into the 25th, 26th, and then we'll start to dive back into the sun, but we still have a chance to see it. So let's talk about what this planet is all about, so we'll fly right to it in space. Now that we're in space digitally using our planetarium software UniView, we can fly to where Mercury is around the sun. So let's take a look as we head over to that area of our solar system. And as you know, Mercury is the closest planet to our sun, so it has a very tight orbit to it. That means that it can move very quickly around our sun because it feels so much of the sun's gravitational pull, more than any other planet in the solar system. And we can see it as this orbit here. You can see these green orbit drawings, and Mercury's is very, very close. Now, this orbit is the most elliptical out of all of the orbits of the planets, which means that it's most oval shaped. At its closest to the sun, which is called perihelion, Mercury is about 28 or 29 million miles from the sun, but at its farthest distance, way out here, that's called aphelion, that is where Mercury gets out to about 43 million miles away. So it's quite a difference between closest and farthest approach. And since Mercury is so very close to the sun, it really moves at lightning pace around it, at least compared to the other planets. So we'll just speed up time real quickly here, and we can watch the orbit. And for Mercury, it only takes about 88 days to go around the sun one time. That's one Mercurian year. So on Earth, you have 4 Mercurian birthdays every year because it takes about 3 months of our months for Mercury to go around the sun one time. So you get a lot of Mercurian birthdays every Earth year. And to compare with Earth's 365-day year, Earth travels at about 67,000 miles per hour around the sun. That translates to about 30 kilometers per second. Sounds pretty fast, and it is. But compared to Mercury, Mercury is about 47 kilometers per second, which translates to about 105,000 miles per hour on average. Now that can change. When Mercury is closer to the sun, it actually goes faster, and when it's farther from the sun, it actually goes a little bit slower. But on average, it's more than 100,000 miles per hour, much quicker than Earth going around the sun. And due to Mercury's fast movement because of its proximity to the sun, that is why in the sky, Mercury never stays in the same spot very long and moves back and forth between the evening and morning sky just faster than any other planet. And ancient observers noticed this, ancient Greeks and the Romans, named it after their messenger god. To the Greeks, this was Hermes. To the Romans, this is Mercury. The messenger god was the one who relayed information between the gods and who had wings on his sandals or wings on his feet and moved at such a blistering pace. So they named this fast-moving planet after their fastest god, that we still use that name today, at least the Roman name of Mercury. For the longest time, we really did not know what Mercury looked like because of its proximity to the sun. The sun's glare would not allow us to see it easily through telescopes from Earth. And that'll change during the space age when we're able to send spacecraft to the planet to take photos of the surface from above. In the mid-1970s, we had the Mariner 10 spacecraft from NASA image half the planet. In 2011, the NASA spacecraft called Messenger entered orbit around Mercury and imaged the entire surface of the planet in high resolution, which has given us a greater understanding of the planet and how planets like Mercury work. And it tells us also about the formation of our sun and the rest of the planets in our solar system. So what we'll do is we'll take a little closer look at Mercury by flying right to it. So let's take a little journey there to this close planet to the sun here. And once we get there, people automatically think that I am flying them to the moon. Every time I do this in the planetarium or I show this in a presentation, this is the automatic response that Mercury looks just like the moon. And it's very similar in a lot of ways. They're very close in size. Mercury is much more dense, but they have these very heavily cratered surfaces, gray and dusty. They're both airless worlds with extreme hot and cold temperatures. Mercury's is much more extreme though because of its close proximity. It's only a third of the distance on average from the sun than we are. So on the sunny side of Mercury, it gets up to about 800 degrees Fahrenheit, blazing hot. And on the night side of Mercury, because there's no air to insulate any temperature or regulate the temperature, it gets very cold in the negative 200 or 300 degrees Fahrenheit. So you can have very extreme temperature variations between one side and the other. And as you see, as we were flying over the planet, you can see how heavily cratered. Actually, Mercury on average has very large craters because the planet moves so quickly around the sun. It rams into asteroids and comets and little rocky bits much, much faster. So it hits into them so hard, the energy from impact is greater. And there is no atmosphere around Mercury to burn up the rocks as they pummel the planet. So it makes for a very heavily cratered surface, one that's quite interesting, and again, one that looks very similar to our own moon. Now, I mentioned that Mercury is very hot, and it is, and you'd think with a planet so close to the sun that there would be no water at all. But what was very surprising from recent missions to the planet was that near the poles of Mercury, where there are certain craters that never experience or never get any light from the sun. So there are permanently shadowed craters in the poles of Mercury, and those permanently shadowed areas, also called cold traps, always stay at a temperature below negative 170 degrees, at least Celsius. And since that's the case, and since Mercury is getting bombarded by icy debris over time, at least one idea is that debris has been raining down in certain areas where the ices and the water is not evaporated by the sun. And so you get these really interesting cold trap areas that exist in these permanently shadowed craters that are on the poles of Mercury. And that was quite surprising. There could be tons and tons of water there just from the accumulation of little bits of ice raining down in the right places on the planet. Now, one of my favorite things about the planet is if you were on the surface of it throughout an entire Mercurian year or even longer, you'd have a very interesting day, because the day of Mercury is quite slow. It actually spins very, very slowly. It takes 58 of our days to go around one time. And remember, its year is only about 88 of our days. So its rotation, or its day, is about 2/3 as much as its year, which again can make some really interesting things happen with the position of the sun in Mercury's sky. So what we can actually do is head to the surface or land on the surface of Mercury and just go to the right time where the sun is kind of in an interesting place. So we're going to switch to a time of the year where we're in a certain part of the orbit. And as I mentioned earlier, Mercury's orbit is quite oval shaped. It's quite elliptical. So when Mercury is closer to the sun, Mercury goes faster around it. When it's farther, it goes slower. So that means that the sun can change its movement in the sky as Mercury goes around it. So to show you this, I'm going to speed up time, and this is sitting on the surface of Mercury looking at the sun. So it'd be very, very hot if you were doing this in real life, of course. And we're going to speed up the time. What will happen is throughout the Mercurian year, the sun will travel in a certain direction, and it will continue to do that. But eventually, as Mercury gets closer to the sun, its movement speeds up and it actually outpaces its rotation just for a little bit. So what that means is the sun will eventually come to a stop in the sky, reverse direction as it's doing right now, then stop again, and then go back in the other direction when Mercury slows down in its orbit once again. That will happen in just a moment. There it goes, right back where it was going earlier as we were moving around the sun. So the sun does all sorts of very interesting things, and it takes 2 Mercurian years for the sun to go around you, all the way around you, if you lived on Mercury. So the orbit and the rotation makes for some very interesting sky dynamics living on the surface of the closest planet to our sun. Now that we're back home here on Earth, looking at Mercury once again in our evening sky this week, now you can understand how the fastest planet that moves around the sun works and what it's like to be on it as you looked at the sun from the Mercurian perspective. So as we go through the rest of the week, you will still have a chance to see Mercury, but what you'll notice is each evening it'll start to descend very quickly towards the sun. So this is on the 26th, on the 27th, the same time, about 30 or 40 minutes after sunset. And as we continue through the week here and then into the weekend, you'll see it just kind of drift further and further into that sun's glare until eventually it just gets harder and harder to see as we end up in February coming up soon. As we make our way through early 2021, what is great is we still have a wonderful view of the red planet Mars in our sky. You can see it pretty high up after sunset and for a good part of the evening. And what is really exciting is less than a month away, we have that Perseverance rover landing on Mars, this NASA rover that will land on February 18th. And what it will do is look for past signs of ancient microbial life as it drives around on the Jezero crater. And so it's a very exciting mission with a lot of firsts that are happening. It's going to bring with it a drone helicopter that will fly eventually, and many experiments and science instruments that can help us to understand the surface of Mars and maybe if life ever existed there in the past. So it's a really cool mission that's coming up, and it's great that we can see Mars in the sky while this is happening. We have a great view of it. Here's just a more zoomed in image of this planet, this world that was a lot like Earth billions of years ago and died, basically. Lost its magnetic field, lost its atmosphere, dried up, got really cold, and has become a barren world. But it may preserve some of those ancient forms of life if they ever existed there. And hopefully the Perseverance rover will detect those signs and maybe even set up some materials that will be brought back to Earth some years later, maybe by end of 2020 or into the 2030s. So exciting time for Mars. We can still see it in the sky, and just get ready for that Perseverance rover landing on February 18th. We're going to be talking more about it leading up to the landing. And rounding out this episode, on Thursday, the 28th, we have a full moon. And of course, that is when the moon is opposite of the sun in the sky. And that's the only time when you can see the moon for the entire night. So that will happen on Thursday. And you'll see it rising out of the east, kind of northeastern part of our sky. And when there is a full moon, of course, there's much more light coming from it, at least that reflected light from the sun. So for astronomers, usually not a time to bring out telescopes and to point to things and to study things because the light pollution from the moon is quite extensive. But If you're just wanting a beautiful evening to go out with a little bit more natural light, a full moon is great. And a full moon like this, when you look at it low in the horizon, will look very large to your eyes if you're waiting for it to rise because of that moon illusion that we've spoken about before. Your mind thinks it looks bigger than it really is, low, and it makes it look abnormally large. And you'll get kind of that reddish color on the moon because when the moon is rising or setting, you're looking at it through more atmosphere. So those two things make a full moon look really interesting as it's rising out of the east. And as you also may know, full moons throughout the year have names. You have the strawberry moon, the harvest moon, the full corn moon, you may have heard of that one too. And they represent various things throughout the year, from Native American traditions, from European traditions, farmers, and some of their traditions as well. So commonly for January, the full moon is called the wolf moon. At this time of the year, at least for Native Americans and people around the world, notice that if you had wolves in your area, they tend to howl quite a bit, at least for those in the northern hemisphere in the wintertime. A lot of howling wolves, and this name for the moon kind of reflected that time of the year, the time when wolves were really making kind of a ruckus outside and can be heard. And so the full wolf moon is one of my favorite named moons you always find in January, and we have it coming up here as it rises in the east on the 28th. And if you want to know exactly where the moon is in the sky, let's just bring the moon up a little bit higher up in the evening. And it's actually embedded kind of in between two late winter and really spring constellations. Actually, the moon is pretty close to a constellation here that I'll click on. This is Cancer the Crab, and not far from it are some stars that look like a hook shape, almost like a backwards question mark. That is the head of something called Leo the Lion. And so the moon is pretty close between those two constellations as it is full on that night. Hey, that's it for another edition of Our Sky Tonight. We really appreciate you tuning in, and if you're in the area, please stop on by the Lohman Planetarium. We are running shows safely every day. Check out our schedule online if you want to look up what we're playing, and hope to see you here next week. Take care, happy Mercury viewing, and happy stargazing.